My name is Isabel Romero, and I'll be covering convergent plate boundaries. Convergent plate boundaries are zones where two tectonic plates move towards each other. When the convergent plate boundaries collide, the crust is destroyed as one plate is pulled underneath the other usually. The types of collisions depend on the types of plates involved. The types of lithosphere that is met is the result of either continental to continental plate boundaries, oceanic to continental plate boundaries, and or oceanic to oceanic plate boundaries. First, we will explore and see what happens when oceanic crust meets continental crust, where two ocean plates meet, and also where two continental crusts meet. Continental to continental plate conversion is when two plates collide together. Neither will buckle down or create subduction due to both continental lithospheres having like density, and therefore the crust will get pushed up and to the sides, as you can see in the image here. The colliding of the two plates will eventually form a mountain over time. An example of a continental plate conversion is seen here in India. When Pangaea started to break apart, the Indian plates started to move northwards, and about 50 million years ago it collided into the Eurasian plate. The collision between both plates caused the Earth's crust to buckle upwards. As the Eurasian plate crushed against the Indian plate, they started to form mountains. The continuous collision between both plates have resulted in the formation of the Himalayan mountain range, as you can see here. The Himalayas are the highest mountains in the world. The highest peak is Mount Everest, which stands at 8,848 meters. Since the Indian plate is continuously colliding into the Eurasian plate, the Himalayas continue to grow at a rate of approximately 5 to 20 millimeters a year. The location where the two continental plates collide, earthquakes are typically deep and extremely powerful. Next, we will look at oceanic continental plate convergence. When oceanic plate collides with continental plates, the crust forming the oceanic plate gets bent downwards and pulled underneath the continental crust, as you can see in the image. This is also known as subduction. The zone at which point this occurs is called the subduction zone, as noted in the image. This happens because the lithosphere that forms the oceanic crust are denser and thinner than the lithosphere that form the continental crust. At the subduction zone, where the oceanic crust sinks beneath the continental crust, a deep trench or valley is created. The trench can be thousands of kilometers long, and it can also be 8 to 10 kilometers deep, making it the deepest part of the ocean floor. Oceanic and continental plate collisions produce mountains and volcano formations, as you can see. Mountains are formed as the overriding continental plate gets lifted up over the oceanic plate. The South American continental plate and the Nazca oceanic plate is a prime example of the collision between oceanic and continental plates. The South American continental plate is being lifted over the subducted Nazca ocean plate, as you can see here, having created the Andes mountain range. Some of the deepest and most powerful earthquakes occur at the subduction zone. Finally, we will review oceanic plate conversion. The oceanic conversions are similar to continental conversions, as one of the plates is subducted under the other during the collision. As we can see here in the image, at the subduction zone right here, there's a very deep trench that is formed on the ocean floor. Oceanic plate conversion results in the formation of volcano chains or volcanic arc. The crust that is subducted melts to form magma. This magma rises to the top of the overriding oceanic plates and erupts on the ocean floor. over time, meaning anywhere from 1 million to millions of years, the lava and debris from the volcanic eruptions pile up on the ocean floor until the volcano rises above sea level to form a volcanic arc. They typically are parallel to the ocean floor trench at the subduction zone. An example of oceanic plate conversion is seen at the Aleutian Arc in the state of Alaska. As you can see here, the trench at the bottom of the ocean floor runs right along the line of the volcanic islands up above. The oceanic plate conversion experiences similar powerful earthquakes to those of oceanic and continental conversion. This is my coverage of conversion plate boundaries. I thank you for your time. Here's my works cited. The majority of the information on my presentation was drawn from geology.com, also from our textbook, Essentials of Geology, and all images are the results of Creative Commons licenses.